Hello, this is Don Panji from LPA Software Solutions, and I welcome you to our Analytics in Manufacturing webinar. We're talking about how to become a data-driven organization as a manufacturer. I'm here today with our Director of Predictive Analytics, David Russell, and David will be joining us in a bit and introduce himself. Before we jump right in, let me tell you who LPA is. We're an IBM analytics and information management reseller and consulting organization. We've been around 15 plus years focusing on analytics consulting. We have over 300 clients from large in the enterprise market to smaller in the mid-market. We've added over 40 clients in 2015 and 2016 again. We have a very high client satisfaction with our analytics consulting. We have knowledge across multiple industries. Today, we're focused on the manufacturing industry. However, analytics and information management as a whole is pretty much universally utilized across manufacturing, public sector, government, healthcare, and you name it. LPA is a partner, a gold partner with IBM. So we focus on IBM analytics tools. We also are a partner with Pitney Bowes, who has some very advanced geospatial location analytics tools that play very well when you're doing analytics solutions. Our folks are 100% certified. We have well over 100 technical certifications. We have consultants of multiple skill levels, but most of our consultants have 10 plus years. This is what we do, and we do it very well, which is business analytics and data warehouse consulting. In the data warehouse area, we also do ETL, and of course in the analytics areas, predictive analytics, business intelligence, financial performance management, cognitive computing. We've become such experts in these fields that IBM themselves uses us to implement their analytics solutions to a lot of their partners and clients. So with that, I'm going to introduce David Russell, and then I'll come back to you at the end of this presentation. Thank you very much and enjoy the webinar.
Thank you, and welcome everyone. My name is David Russell, and I'm the Director of Predictive Analytics at LPA Software Solutions. Over the past 20 years, I have worked in a variety of fields as a software developer, database architect, data analyst, and systems integrator. For the past 5 years, I've been primarily focused on using the suite of IBM analytics tools to focus on predictive analytics solutions across a variety of industries. Today we're going to be talking about analytics in manufacturing. To start that discussion, we should probably come up with a consistent definition of analytics that we're going to be using. That really comes down to the answer that Google provides, which is the systematic computational analysis of data or statistics. We can go a little further than that, and we use that as a noun that describes the products of that systematic analysis. And you can see from the graph of the usage of this term that it's been increasing through the 20th century. And the late 1990s, when data mining really became a term that started to be used, analytics was used more and more, and it's been growing ever since. That phrase or that term is used to describe everything from the reports that you get daily that might have statistics or measures of what's going on in your business, to the predictive analysis that tells you or forecasts what's going to be happening next week. All of those fall under the umbrella of analytics. When you start looking at analytics, you sort of have a maturity that you can look at in any business, and manufacturing is not different from anything else in this way. You start with the information layer. This is how you organize your data and integrate new data sources into your analyses. That can include everything from traditional relational databases to big data platforms like Hadoop today. IBM certainly provides a number of capabilities in this space, from DB2 in the traditional relational database to Big Insights, which is their branded version of Hadoop with additional value-added capabilities around the Hadoop services, to database appliances or analytics appliances like Pure Data Systems for Analytics, which used to be called Netezza, which provides a massively parallel relational database engine. You can then move up as you get greater value to your business. You can move up to descriptive analysis, and in that analytics space, you're talking about your standard reports, your alerts, your drill down capability, and things that you might do with ad hoc reports to look at the data in the database or in your big data application and pull information out. The primary tool within IBM's suite is IBM Cognos Analytics for creating these descriptive analytics. As you move up that stack, you can get into the predictive space. This is where you're starting to take your past and present data and really move to look towards the future and be able to predict what might happen with data. And that certainly is something that has a greater business value. This is where you get into your machine learning capabilities, your different forecasting, as well as just traditional statistical analysis falls into predictive frequently. When you get into this space, IBM's tool set includes the SPSS statistics and modeler tools, Watson Analytics, which sort of fits in descriptive and predictive, is a cloud-based tool for doing smart data discovery that can be interesting in this predictive area. You also have the data science experience, which is really a cloud-based system focused on the data scientist who wants to analyze their data and produce additional predictive models from that data. It provides a lot of access to open source tools as well as IBM proprietary tools that provide you additional capabilities. Then you get to prescriptive data. The next level up from that has additional value as well and starts looking to the future some more. This is where you're taking your predictions, taking what you think is going to happen in the future, and rather than you then making a decision and doing something about that, you can come up with ways to optimize your decisions or come up with rules that say, okay, if I predict this, I should do this, and you can have the system automatically perform that operation. In the simpler area, you can talk about insurance space where you take a claims that are coming in or a new claim that's coming in and you analyze it, and based on what you've seen happen in the past, be able to categorize that claim as being one that's likely to be fraudulent or one that is likely to be perfectly fine and not have any fraudulent activity associated with it. And those that are fine, that have no risk of fraudulent activity, could be pushed directly to be paid without any additional work, and that can save you time and money. Whereas those that are likely to have something that needs more investigation, you can push that to your fraud department so that they already know that they're working with a case that really might have an issue rather than trying to deal with a deluge of claims that have no reason to be analyzed for fraud, and actually, they don't need to do that additional investigative work. That can save some time and can optimize your operational benefits. You can also see optimization just in the area of manufacturing specifically. You can start to optimize your production of different goods and service and goods that you're going to be providing through different rules and through different predictions of what's likely to be needed and what the demand is. Above that level, IBM talks about the cognitive space. In the cognitive space, we have Watson, which is the underlying machine learning system that makes predictions and learns from things that you tell it. So you're really reasoning and learning and doing natural language processing when you get to the cognitive space. And this is where the system is self-learning and always refining answers rather than having to go back and retrain or retest your statistical analyses like you typically do in the predictive space. Ultimately, your data and your analytics are your foundation for becoming a data-driven business. Today, that is really one of the big pushes, is to get away from making decisions based on intuition or gut feel, and being able to provide rationale from your data as to why you're making those decisions. And your different types of analytics, whether it be descriptive, predictive, prescriptive, or cognitive, all provide that capability to drive your business forward and to provide you the information you need to take action. But all of those different types of analytics require that you have data to drive them. And that data that's underneath, it comes in a number of different varieties and from different sources. You have the data that you possess. That's data that you're generating within your business. That's either from, in your manufacturing facilities, you might have machine data that you're generating all the time from your equipment that's doing the production. You have customer records and financial information from your back office about what's happening in your business. You have HR information that might be interesting to talk about when you look at churn of your employees, or even employee satisfaction, or employee retention. All of those things ultimately can have impacts on your manufacturing, as well as other things that you have from your other institutional expertise. So just information that you've collected from people about rules that they've sort of built for themselves. Some of those gut feel, if you will, that you can start to feed into your system and start to validate that against your other data and see how it fits in. You have data that helps you compete. This is data from outside of your business that might be used to develop more information and to be used in different analytics. That can be news or current events, image data or social media. Those are less critical in manufacturing frequently, although you can apply them, the image data and social media, in some ways. Certainly news and events can be used when you're doing demand forecasting, when you're trying to understand what products you should be producing. Those are some of the things that you can look at to see what's happening in the world, that you might be able to produce analytics to help you see how those changes in the data from outside is affecting your operations internally. Then you have also data that's in motion. So a lot of this data is similar to the data that you possess, but it's really about the data that is changing over time, changing quickly, and also has potentially a fairly short lifespan of being useful. So everything from some of that Internet of Things data that might be coming in from products that you've produced and put in the field that are reporting back to you, that information may be fleeting in its importance. Uh, from a operational perspective, you may find that it's useful to store and analyze from a predictive perspective. But while that data is in motion, it can be applied, and analytics can be applied to that to help you understand what's going on in the world. You have your sensory data, which is very similar to that Internet of Things data. You have geospatial data about where people are, and then weather data is also one that's always changing, always in motion, but it can also be very valuable. There are, certainly things where manufacturing is being impacted by weather events. Even IBM internally years ago had issues with chip manufacturing, and they were looking for what the impact and why they seem to have these real problems with production quality in certain instances, and it seemed to be associated with snowstorms. Now, that's a weather event that has an impact. What they ultimately found the problem was that in their clean rooms during snowstorms, they would have the salt that they would lay on the roads. And some of the ions that were being released as part of that salt that was built up during the snow clearing operation, some of that was being brought into their chip manufacturing and was actually creating problems with their underlying process. So understanding those relationships and identifying them as they're occurring, rather than, like in the case of IBM, where they spent months, if not years, investigating to figure out that relationship, that can be important. Maybe they didn't need to know that it was really those ions, at least initially, that were creating the problem. They just needed to know there was a relationship between snowstorms and their production they could create a response and then worry about figuring out exactly what the problem was so that they could potentially account for it and prevent the problem in the future. That's a separate thing from just changing your manufacturing so that you're not wasting raw materials potentially. Everybody's saying that they want to become more data driven and that they want to have a digital transformation in their business. Problem is, there's some inhibitors that are definitely there in most businesses. And this is from a study from the Harvard Business Review. And 80% find that they're unable to collaborate on common data. Usually this has to do with having differing definitions for a customer, for example, where you need to talk about who your customer is, and finance thinks of customers differently from manufacturing. Uh, that falls into this 84% say fragmented data gets in the way. It's a very similar problem. You can't collaborate on the data, but part of the reason you need to be able to collaborate on the data, or problems of not being able to collaborate on the data, all comes from this data being fragmented across the different portions of your business. You have different pieces of information held by different organizations within your business, and trying to bring that together in a fashion that allows you to make these types of decisions, it can be difficult. But we also know that more than 9 out of 10 businesses require faster and data and analytics in order to be able to compete, because there are businesses out there that are using data to their advantage and finding ways to use that data. And as they are able to use that data better, those that are competing with them have to keep up in order to not lose ground. So as you're becoming more data driven, what does this analytics journey look like? How do you move from being simply intuition driven or using your typical techniques of analysis? How do you move to being more data driven and you having the data lead you in your business? And you can start by improving your efficiency with your operations. At your operations level, that means improving your databases, improving your process of recording the data potentially, and thinking towards what are you going to need in the future for providing analytics. The next step is modernization of your systems. That can start with your reporting and data warehousing environment. That can move to a more ad hoc, friendly, or self-service model for analytics and reporting, as well as having your data warehouse, making sure that you're taking advantage of any of the massively parallel processing systems that are available, whether those be data analytics appliances that are more like traditional relational databases, or if those are big data systems like Hadoop. As you move to those new systems, what's most efficient for you, what provides you the most value as you modernize. The next step is really moving farther towards the self-service analytics. I talked about bringing in tools to provide that, but it's really about democratization across the board. So enabling your user base to be able to use that data to analyze data themselves and make decisions without necessarily having to wait for IT to answer questions about data and pull data together, making it available so that individuals in your organization can pull data together across disparate systems and make good business decisions, or at least to research new business decisions that can be made based on that data. And then the last step is really this monetization. How do you build new business models around the data that you have? You certainly see new business models based around data being developed all the time. Everything from Apple with the iPhone and all the data that they're collecting from that device, and then building back into their back end systems. Everything from the iTunes and the Google, and the not Google, but Apple Music, providing you the capability to select music that's of interest to you, and using data that they're collecting about you to make those decisions. And they can charge additional money for that and create a new business model around that. You also have Tesla as a manufacturing firm. They're producing cars now that you have a relationship with that consumer for the lifetime of that vehicle being owned. And that relationship includes monetized data about who they are, where they go, and what do they do that keeps those customers coming back to Tesla for more and more capabilities. And all of this comes into different things that you're working on. You have your data foundation at your operations level, making sure that you're ready for analytics and that you're collecting data efficiently to provide you information for your analytics, to your data lake and your more modern data warehouse environment, focusing on data science as you're moving into self-service analytics, and then making your data work for you, even beyond making just better business decisions, but potentially building whole new models for your business and how you make money. So we certainly see data analytics having a significant place in manufacturing today. Many people talk about this as Industry 4.0. There are four primary areas or initiatives within this Industry 4.0, starting with interoperability. This is the ability for integrated people, machines, and systems across your manufacturing capability. This interoperability can be between machines within a facility or even across manufacturing facilities, so that you can pass data and have data shared in such a way that it can improve your production capability. That comes with information transparency, which is the next initiative. That data has to be data that can be shared in a way that the information is useful to other people, and that transparency allows for systems to interoperate. And it also starts to talk about making these cyber physical systems that can be used to analyze data in the cyber space to predict what's happening in the real world and to be able to use that to better plan and better prepare for production. You also have this initiative for technical assistance. This is just making sure that your equipment can be operated efficiently and that you can provide visual tools that are rich and powerful enough that people can learn to use the equipment effectively and efficiently, regardless of the particular product that's being produced by a piece of equipment. And we also have this decentralized decision making. So we're moving away from needing to have a planner that sits and has particular pieces of equipment that they know how to plan for, and move to a world where you have enough data and you have enough capability to decentralize those decisions about what needs to be produced when on which line, to make that something that can be done at a higher level, so that you can even make decisions about what an entire plant needs to be producing from a higher level and a higher perspective. Now, manufacturing really covers a lot of different spaces. When we talk about manufacturing, that's really one business operation within a larger organization. And your analytics that we're talking about can drive changes across all of those areas within your business. They can drive changes, as we're talking about there with Industry 4.0, specific to manufacturing, where we're talking about equipment and processes that are involved in creating the products that you sell. But you can also see improvements using analytics in warranty service claims, where you're dealing with connected machines and you're able to produce additional performance metrics and do preventative maintenance to improve your warranty claims and other things. A good example there with an IBM's been working with Whirlpool. They've been working with washing machines, I believe. But they have their production line where they have their standard tests that are performed on every piece of equipment that are sort of their quality checks before that line leaves. Each one of the different metrics, they're about somewhere between 12 and 20 metrics that they're measuring. Each of those individually has guidelines for what is acceptable quality for each of those tests. And as long as the piece of equipment passes all of those tests, then it's good to go and it leaves the line. They do also individual samples where they pull off a piece of or a particular washing machine that's been produced, and they do deeper testing on that to validate the production quality. Um, but what they're finding is that they have warranty claims down the road, even though they have these quality checks that they have on their line. So they started looking at what are the relationships between the values that they record in those quality tests versus those machines that eventually end up being warranty claims. And they actually found some interesting patterns that they were able to see certain combinations of test results, and specific numbers for those test results, not just pass fail, were related to warranty claims. And they then changed their process to start pulling machines that met these certain criterias off the line for this deeper testing. And they found that they did have some production issues that were cross-correlated across their tests. And this is allowing them to run these predictive models in such a way they can predict what's going to be a warranty claim and head it off before it gets out into the field. You also see predictive modeling being used in supply chain and inventory, where you're predicting your demand and you're predicting as well as your supply and the inventory that you need to have on hand given certain conditions. And that allows you to be more efficient in what you do. You see analytics being used in finance. You also see it in sales and in operations as well, where in a manufacturing world, your operations, you may be talking about your human resources and your ability to analyze who's likely to be your best employees and who's likely to be the ones that you need to move up more quickly and who's likely to churn, so that you can make decisions about whether you need to step in and figure out how to keep somebody that's critical to your business, or whether you should perhaps just let them leave, as the case may be. So next we're going to focus on a few use cases that are out there that we have, and these use cases cover a number of different areas, primarily around manufacturing and different things that LPA has done, but several of these are IBM use cases as well. First, we're going to talk about in electronics manufacturing, using analytics primarily in their financial space for looking at visibility of their cash flow. We're going to talk about heavy equipment manufacturing that we worked with. Again, in this case, we're working with analytics in their data warehousing and business intelligence area to help them improve their business processes around their manufacturing. We have an example of predictive analytics for preventive maintenance with an IBM global OEM. We had LPA work with a food manufacturer. We worked with them on predicting downtime in their plant. And the last use case is going to be one with IBM with a truck manufacturer looking to reduce warranty costs. So the first use case is this electronics manufacturer. As I mentioned, their primary, the business themselves, they are electronic manufacturer, and they work with advanced technology across a number of different industries. And they specialize in custom manufacture of high reliability complex circuit boards. So within this business, their problem that they had was they needed to try to get a better handle on their financial operations, and they wanted to make sure they could manage their cash flow better. So we worked with them, and we worked with a particular IBM product, IBM Cognos Express, which includes IBM Cognos BI, as well as the planning analytics platform, also known as TM1. And we worked with the CFO to create a set of reports that would allow them to more accurately measure and track and plan for their cash flow within their business. And this was using analytics of their past data to help them with their budgeting and forecasting process, and being able to report on that historical data in a fashion that allowed them to more easily see where problems might occur and what they need to be paying attention to. LPA's also worked with a heavy equipment manufacturer in Texas. They develop, manufacture, and distribute high-quality material handling machines, forklifts, for those of you that aren't in that particular field. In this case, they really were looking to just improve their reporting. They needed better insight in general into the business and the operations across the board, whether it be financial or operational reporting they needed to have. And we found that they were sort of lacking with their data warehouse, and they really needed to improve their data warehouse first, and then put better analytics on top of that. So, we worked with them to develop a best practice approach to using short sprints so we could build value quickly, to develop a data warehouse first, and then to build reporting on top of that. We started out with the financials first. We worked with the Office of the CFO, and we helped them to build out better reporting and better capabilities to get insight into their business. And then we moved on to look at quality and manufacturing and other areas of their business to help them span their entire enterprise with better reporting and better insight into their business. IBM's worked with a global machine OEM, so they've used the IBM cloud to improve their processing of their data. And so their goal was to reduce machine downtime by predicting demand for spare parts. This makes sure that they have the right parts in the right place at the right time so they can service their equipment in the field. And so what they were looking for was leading indicators based on both machine usage and maintenance and things like that to identify the parts and the services that would be required and when they would be required. So IBM helped them to load that into their cloud, and they were able to perform an iterative analysis on 4 terabytes of data in less than a day. And that analysis allowed them to be able to predict things about equipment usage that would allow them to provide their spare parts and to provide better service to their clients. Now back to LPA's use cases. We've worked with a national food manufacturer. They're a leading supplier of solutions for food service, in-store bakery, and retail. They have more than 10,000 employees, and they're a $3.5 billion company. One of the issues that they came to us to talk about was unplanned downtime. So they have a process in place where when their production lines go down for more than 3 minutes, they are required to go through a process of root cause analysis to document the downtime, to document what the root cause was and what they did to fix the problem, and how they got the line back up and running, and the time that each of those steps took in getting there. But that also means that for downtime of less than 3 minutes, they really don't have a whole lot of data about those, because those are considered relatively insignificant. They happen, the machine comes back up, and the production continues, and they're fine. But the issue there is over time, those small downtimes add up to more significant amounts of downtime. We actually found that over the course of a month, that those small bits of downtime could add up to an average of 6 hours of downtime across all the lines within a plant. So what we were trying to do was build a model to predict downtime based on the data that they were already recording, that they already had about their production lines. So we went back and looked at 6 months of data to try to build this model. And we were hoping to provide a model that would predict a few hours ahead of time what the downtime was going to be, and why the downtime might occur, so that they could do something to overcome that. What we found was we could predict the downtime, but not with that much lead time. The interesting thing, though, was that predictive model, while it didn't allow us necessarily to prevent the downtime in the short term, it did highlight what pieces of equipment were causing the downtime. So we were able to build an association between the parts and those particular signals coming from particular sensors in parts of the manufacturing line that were indicative of these shorter downtime periods, and allowed people to more easily find the root cause of those downtimes and repair those and to fix the problem. So the last example is another IBM example. This is a truck manufacturer needing to look at root cause analysis, and they were looking at warranty claims in particular. So they have their vehicle data from all of the different vehicles that they've produced. They have both the onboard computer records, they have the records of any tests that were run during the manufacturing process on that. They combine that with warranty claims to try to understand what were the things that might cause these warranty claims and how could they prevent them sooner. And in the end, using all of that analysis and the analytics available, they were able to reduce their annual warranty costs by over $10 million. So what's your takeaway from all of this? Well, the first is that analytics is definitely a driver in the manufacturing industry. Everything from Industry 4.0 and the changes being made there that are all about being data driven to the things that you can do in your business to become more data driven starting today. The reality is no matter where you are in developing that capability of being more data driven and using analytics in your business, you can start becoming more data driven and becoming that data driven organization regardless of where you start. When you start out with operations and you're working on your efficiency, LPA can even help you to evaluate your back office and operational systems that need to support analytics, and you can work to make sure that you understand what you're going to want to analyze in the future and what analytics you're going to want to perform. And so you need to think about what data do you need to collect today and how can we improve our systems so they collect that data in a way that supports us in the future. We can move forward in your data warehouse and your modernization of that data warehouse, and we can help you with your data readiness. We can help to assess the availability of data sources and those things that will be supporting analytics in the future. And we can also look at innovative data technologies that you may need, whether that be your Hadoop clusters and your different cloud systems and predictive tools that you can apply, and how can you make that data cleaner even to make sure that it's ready for analytics in the future. The next step is to create more insight-driven operations, and so that we can certainly help to recommend best practices to access data and to apply analytics to exploit anything that you're doing in your data for any operation that you're performing in your business. And that includes many of the different tools from IBM that we've discussed already. And we really want to help you to become more insight-driven to drive your business with your data. And the last step is, how do we truly become data-driven? How do we really build new capabilities internally from our data, as well as potentially launching entirely new business models based on the data that we are already collecting and analytics that we can perform on that data, because that can truly transform your business and change the way you work. As I said, wherever you are, you can start this journey and you can move forward throughout this to increase your business capability through data and through the analytics that you can apply to that data. So as we're wrapping up, getting distracted a little bit here by questions, trying to answer some of those questions for you that have come in. If you have questions, if you haven't already entered them in the chat box, feel free to do that. If I don't get to all of your questions, we can respond to you later via email. I do have a question here about the data warehouse portion. A lot of people questions specifically around what data do you put in a Hadoop versus a traditional data warehouse, and how do you make that decision? And there are a lot of different things and different aspects of that decision. If you have nothing but structured data that is already in a relational database, staying in a relational database makes sense. We talk about moving to a data warehouse, a modern data warehouse with Hadoop clusters and these distributed systems. But that may not be right for every business to move there. There are some advantages even if you are working with structured data that can be applied. If you have a growth model that says that today you're going to analyze a little bit of data, and you're going to be performing analytics on a small data set, and that data set is going to grow potentially quickly over time. But you don't want to invest in the hardware that would be required to analyze that efficiently in the future. That is one advantage of something like a Hadoop cluster. It allows you to grow more slowly because it's using commodity hardware that can be clustered to create a larger environment. You can add machines as you go. So in that environment, you might start with a single node, a single machine doing the analysis, and then grow that over time. So there may be a place in that situation. On the flip side, a Hadoop cluster is great for unstructured data or for data that you don't know how you're going to analyze, that it's streaming in and you think you know that if you keep the data, not just think, but if you know that if you keep the data, you're going to eventually be able to get access to analytics that will allow value to be extracted from data, but you're not sure how to organize that data today. That is really the prime candidate for creating a Hadoop cluster to allow you to store that data in a way that can be efficiently analyzed, even if you don't have a specific format in mind or a way that you're going to analyze it today. And so, I'm answering the question in a very consultancy way. It depends, but the reality is, we talk about it as being, the modern data warehouse has Hadoop in it. You don't have to get there immediately, but there's certainly a place for it for you to collect data, and then because you're going to eventually move to something more similar to a relational database for certain types of operations once you know what data you need and have extracted that from your data sources. And that allows you to analyze it in an efficient manner. So it's really a good question, and it's not an easy one to answer all the time. There are people who tell you must have it one way or the other. I think that there's definitely a place for that hybrid between the two. There's also a place to have just your Hadoop or your parallel clustered environment, or there's also a place for staying with the traditional relational database. It really depends on the nature of your data that you're working with. So I think I'm going to wrap up the questions and hand this back. Thank you for your time today.
Thank you, David. So I hope you've enjoyed our analytics in manufacturing webinar today. Obviously, there are a lot of places you can start, and it's usually best to start from where you are. However, like any other project, it's good to know where you want to go. If you're still not sure and you'd like some assistance in plotting kind of an analytics strategy and roadmap to figure out which analytics projects could provide you the most benefit, especially if you have disagreement across your organization, some departments wanting to go in a certain direction and others in another direction. We've been helping clients either in a very focused, call it one department area, maybe marketing analytics, with about 3-week engagements to help build a strategy and a roadmap to implement, positive ROI projects, or looking across your entire enterprise for doing analytics engagements, looking at the strategy from finance to manufacturing to operations and supply chain and so forth. So we can help build an analytics strategy and roadmap. Certainly reach out to LPA. My information is at the beginning of this webinar as well. You might be in the case where you have a lot of data. You've been collecting data for a long time, but frankly, you're not putting the data to use with executive scorecards or dashboards that provides visibility into how you're doing and trends of things. Certainly, that's right in our sweet spot. We do a lot of work with clients to help do requirements gathering for, and then the subsequent implementation of scorecards and dashboards with appropriate key performance indicators. So that's definitely an area we can help you with. And then finally, you might already have scorecards and dashboards. You're doing a good job with that, but you want to move more into the predictive and prescriptive analytics areas that we talked about today. We have, as evidenced by David leading our team, we have a very strong team that does predictive and prescriptive analytics. And I would just encourage you to reach out to us, and we'll set up a conversation and talk through what is it you'd like to predict. What could really make a difference in your business? We can discuss how difficult or not difficult that may be based upon the data you have and your history in those areas. There's probably a multitude of other ways we could help you, but certainly feel free to reach out to LPA and engage us in a conversation around your analytics needs. With that, thank you very much. We really appreciate your time today, and have a good day.